Okay, guys. Let's see how this goes. New software being used by me. Hopefully this works okay. Just going to go over the at-home worksheet for data management and probability here. A little different. There was a lot of answers for this one. So what I decided to do was take a photo of the answers instead of just working on them, and then work on the photo. So let's see how that goes. Hopefully it works out. Okay, so let's switch to a nice red. And here the first question is, how many tosses of the 2 coins were there? So you got 2 heads 57 times, then you have 1 head 88 times, and 31 times you have no heads. So you toss 57, 88, and 31, 176 times. How many single tosses were there? Well, what you're going to want to do is double this, okay? Because you toss twice 176 times, so you toss once, double that, which is 352. And it says how many heads were recorded in total. So this question is a little interesting. I like it. You had 88 times you had heads come up once. So you're going to count those 88 heads. 31 times you had no heads, so you don't care about that. And 57 times you had 2 heads, so you're going to have to double that. So either add 57 twice or multiply 57 by 2. And when you add those up, you get 202. So 202 out of 352 times, you had a head show up, which is here, which is 57% or 0.57. Okay, and that's a little higher than expected, so that would be experimental probability. Theoretical probability would be 50%. So if you were asked a question like, how would you compare that to theoretical? You would say it's too high. And in the next question, we do the same sort of thing, where you draw 38 cards out of 54, 38 red cards out of 54 draws, which is 70%, and that's too high because half the cards are red, so it should be around 50%. Okay, so over the long run, if you keep flipping coins in the first question, or in the long run, if you draw more cards, you're going to find that your theoretical probability will be approached by experimental. So this 70% experimental probability will come closer and closer to the 50% theoretical. 2 dice. How many times can you get 7? So you can look at your table there. There are 6 ways to get 7, and there are 2 ways to get 11. You add those together, you get 8 out of 36. You can reduce that and have it as a decimal if you like. Reduce that as a fraction and then change it to a decimal if you like. Here, we got to get used to drawing a tree. Okay, so you flip the first coin, okay, or the coin 3 times. First flip, you get head or a tail, head or a tail, head or a tail on the second flip, regardless of if you got a head or a tail on the first flip. Okay, and then you keep going. We've done this a few times in class. I'll just follow one of these branches. So this one here, let me just end up here. This is head, tail, tail. So if you needed to, you could write all this out and say this is 2 tails and a head and answer the question from there. But it just says what's the probability of getting a tail every time. The only time that happens is this branch here, which is TTT, and that's once out of 8. So there's 8 terminal branches, and one of them is the one you're looking for. Okay, so it's 1/8. Queen or a red ace, there are 4 queens, 2 red aces. Add those together, 6 out of 52. Family budget. We looked at this sort of stuff. Now, what kind of graph is the best graph? Family budget. You're probably going to use a circle graph or a pie chart. Okay, I think it's the best way to show it. Not necessarily. You could use, well, I couldn't think of another one, actually, to tell you the truth. Television show preference of classmates. So here are the different, what you want to be careful is if you said pie chart or circle graph, that would work. I was thinking bar graph. Okay, you could have all the television shows here and bars. You would not have a histogram. Okay, so make sure you don't put histogram. Histogram has no spaces. The data here needs spaces because this is categorical data, and there should be gaps between them when you represent them. Child's height, you could use a histogram, but probably you're going to use a line graph for this, right? Make the most sense. What's the most popular type of TV show or movie? Sorry, here you're just going to look at the biggest bar. It's about 225. Okay, give or take a couple on these. How many people chose romance? Just over 50. You could say 50. It's fine. Total, how many were surveyed? I added all these up, and I got about 500. And 148 out of 500 like action movies, which is about 30%. So if your answers are a little different, don't worry about it. That's fine. Mean median mode. Okay, for these here, for 6 and 7, you go ahead and you can work these out. Oh, what's going on here? Work these out. Here are the answers. Okay, for 6A and 6B, not 7. The mean, you're going to take them all up and divide by the number of things. The median will be the middle number. Don't forget, if there's two middle numbers, get the average. Is there a mode? 11 is the mode in B. There is no mode in A. And then the range, remember the range. So let's look at B. The range is 19. You're going to go ahead and, did I even give you B? No, I did not. So just A. Oh, yeah, I did. I'm sorry. What you do is you get the biggest number, which is 25. Okay, you put them in order if you want, but 25 is the biggest number. 6 is the smallest, so 25 minus 6. Some people put that as the range. That's not the range. The range is actually 19. Okay, so this is the answer for range. Okay, so make sure you do that. And then I apologize for this next question here. Actually, let's skip to 8 real quick, and then we'll do 7 because it's the longest. Skewed. Skewed will be skewed right, skewed left. Normal will look like this. Okay, so these guys have tails on the sides. This bimodal, okay, will look like that. 2 modes. Okay, so I apologize for this question here. For number 7, you're going to find the standard deviation just because there's a lot of data points here. Okay, so I will tend to give you less data points on a test. Like you don't need to do it. What is there here? 11 or 12? There's 12 points, which is kind of nuts. Okay, so that's a lot. Okay, you find the mean first. Oh, I'm all over the place here. My pen's going crazy. The mean is 66, so add them up and divide by 12. You get 66. And then what you do here is you make a little table, and then you take each of these points and you write them down. So 91, 47, all the way down. You don't have to put them in any order. Just put them in the order that you see them. And then you take your 66 and you subtract it from 91. Okay, and you get 25. Now, sometimes we do it the other way around where we take our point 91 and subtract it from 66. If you do that, your signs will be different here. I didn't even put signs here. And the reason is we don't really care about this as much as the next column, right? So what we're going to do in the next column is we're going to take this number here and square it. So this should be 66 subtract 91 should be minus 25, okay? But I get a little lazy, and I don't mind if you do the same thing because the 25 and the minus 25 aren't the key. What the key is the square root of this. And when you square a negative number, you're going to get a positive anyway. So I just omitted the signs here. I was just kind of whipping through it. If you want to show the signs, that's great. If not, don't worry about it. Okay, so you put the number here. So 66 subtract 91, or the other way around. Doesn't matter, like I said. Is 25 squared, you get 625. 58, 60, let's jump to this one here. 66 subtract 64 is 2. Square that, you get 4. Okay, so this is the column that matters, is the second column. Add those up, you get 1728. And divide by 12, you get about 12.2. Now, I didn't get the same answer that they did. That's fine. Okay, as long as you're close, it's okay. Okay, because it has to do with rounding and that sort of thing. And that's it. That's all I got for you. I hope that went well, and I hope this video went well. I don't know if it did. Hopefully it did. First time using OBS. All right, take care.